Good morning, Sir Ezra. My name is Rishal Raharja, and today me, Patricia, Irene, and Nathania is going to present on our final exam project. We are going to discuss on the malaria report in Nigeria between 1980 and 2010. We are from Group 9, and we consist of Natasha Irene Santoso, Nathania Angeline Darmawan, Patricia Regina Halim, Pratish Kishore Raisinghani, Rishal Raharja, which is myself, Stephanie Grace Marenga, and last but not least, Vanessa Yulianti. Our presentation consists of the introduction, background, literature review, research methodology, findings and results, conclusions and recommendations, and last but not least, our references. I'll first start with our background on why did we decide on this topic. There are four main reasons on why we decide on this topic. Firstly is because malaria is a disease of a global concern. Historically, in over 100 countries around the world, malaria has killed more people than any other infectious diseases and still accounts for massive levels of mortality and morbidity. Based on the WHO World Malaria Report in 2020, malaria is one of the major health problems and is still continuing to become a major focus of sustainable development goals. The second reason is that highest case of malaria is found in Nigeria. Nigeria is the most populated country in Africa and it has the highest malaria cases in the world. Malaria cases in Nigeria accounts for 25% of the global malaria cases and 24% of the global malaria deaths. Third reason is that the most complete data in the African region. WHO and Institute for Health Matrix and Evaluation provided the most complete data in the African region. Thus, our group is interested to make a report about the malaria in Nigeria. The last reason is that to predict the total deaths of malaria. As we look at the total deaths caused by malaria from the year 1980 to 2010 in Nigeria, we predict the total deaths caused by malaria in the year 2011 and 2012. That's it for the background, and we shall now continue to the research methodology.
I will be explaining about our research methodology. Since our report will look into the total deaths caused by malaria from the year 1980 to 2010, as well as predicting the total deaths caused by malaria in the year 2011 and 2012, the methods that we use is quantitative. To achieve the objectives mentioned above, we apply several methods. First, data are collected from credible sources, and the credible sources used are from Institute for Health Metrics and Evaluation as well as from WHO World Malaria Report. The data is limited to the year 1980 to 2010 and only to the ones in Nigeria. Then they are managed into a table. After that, data are plotted in a graph with total deaths due to malaria as the y-axis and the year as the x-axis. The data are then plotted in Excel in order to estimate its function using the trend line. After the function is found, we evaluate the results that we want to find. Firstly, to predict the deaths due to malaria in Nigeria in the year 2011 and 2012, we apply limits. Next, to find the equation of the tangent line to the total death due to malaria in the year 2007, we apply derivative. Lastly, to estimate the total death due to malaria in Nigeria from 1980 to 2010, we apply integral. And this is a table of the data that we found from the Institute for Health Metrics and Evaluation.
So we finally arrive in the main part from this calculus group project, which is findings or result. So I will explain about the application of calculus in our group project. In the findings and result, we want to explain 4 things that we'll discuss in this calculus group project. So the first thing that we want to discuss is application of function to find the graph function. The second thing that we want to discuss is application of limit to estimate the total deaths in 2011 and 2012. Next, is the application of derivatives to find an equation of the tangent line in 2007, and the last thing that we want to discuss is the application of integral to calculate total deaths of malaria in Nigeria from 1980 until 2010. Before we start to discuss the application of calculus, first we should make the graph. Based on the data before about total deaths due to malaria in Nigeria from 1980 until 2010, we make the graph by plotting those data into x and y axis. We plot year into x-axis and plot the total deaths into y-axis. To make the graph, we use Microsoft Excel as it's easy to use. After the graph has been created, we click on the line to add trend line. Then we choose which trend line suits the graph the most. And finally, we found that the polynomial trend line order 6 is the most suitable trend line according to that graph. After finding the trend line, the function of that graph can be found. How can we get the function equation? So, we basically just click the display equation on chart button, and yes, we finally get the function of the graph. Thus, it can be found that the function of the malaria in Nigeria graph from 1980 till 2010 is y equal to negative 0.0202 x to the power of 6 plus 1.5329 x to the power of 5 minus 43.03 x to the power of 4 plus 549.12 x to the power of 3 minus 2760.1 x to the power of 2 plus 10152x plus 151477. After we finally found the function, we will use this function to calculate or estimate the total deaths in 2011 and 2012. How we get the estimation of the total deaths in 2011 and 2012? The answer is by applying limit concept. Let's start with the total deaths in 2011. From the graph, we assume in 1980, x is equal to 1. So, in the 2011, we can assume that x is equal to 32, and in the 2012, x is equal to 33. In 2011, we input dx equal to 32 into the limit, so it is written like this. Limit x approaches to 32, and then we input 32 into dx. After inputting dx, we can continue to calculate the limit, and finally we got 269,341.448, and we round it to 269,341 deaths. In the 2012, we can estimate the total deaths in Nigeria using the same way as we calculate the 2011 estimation. The difference is we input dx is equal to 33 into the limit, so it is written like this. Limit x approaches to 33. Then we input the 33 into dx. After inputting dx, we can continue to calculate the limit. And finally, we got 87,279.8659, and we rounded to 87,280 deaths. Next is the application of derivatives. By using derivative concept, we can find the equation of the tangent line to the total deaths of malaria in Nigeria in 2007. As you can see from the graph, the tangent line is shown in orange color. To get the equation of the tangent line, there are a few steps. First, we have to find the slope m. The slope can be found by deriving the function. After we derive the function, we get a new function. To get the slope, we input the null point, which is 2007, into the equation. And then in 2007, we can know that dx is equal to 28. Then we input x is equal to 28 into the derived function. And finally, we get y-axis is equal to negative 6127.29. It is the result of the slope. The next step to get the equation of the tangent line is by using y minus y1 is equal to mx minus x1 formula. Because the known point is in 2007, we can see from the table that the total deaths in 2007 is 519,522. So it can be written 28,519,522. After that, we can directly input the x and y into the formula, and we finally get the equation of the tangent line. To the total deaths of malaria in Nigeria function in 2007 is y is equal to negative 6127.29x plus 691,086.12. The last part is the equation of the interferon midpoint rule. We use this midpoint rule to calculate the total deaths of malaria in Nigeria from 1980 until 2010. As you can see from the graph, there are 15 rectangles under the graph with delta x is equal to 2. Then we can directly calculate using this interferon formula, and this dt represents the total deaths in the midpoint year. The midpoint years are 1981, 1983, and 1985 until 2009, which has interval of 2. The calculation is 2 as the delta x is equal to 2 and then multiplied by the sum of the total deaths in the midpoint years. Then we finally get the total death of malaria in Nigeria from 1980 until 2010 is equal to 97,11630 deaths.
So the last part of our presentation is conclusion and recommendations. Conclusion. From this study, we can found the function of the graph of malaria death in Nigeria from 1980 to 2010. By applying limits, we can estimate the total death in Nigeria caused by malaria in 2011 and 2012. By applying derivatives, we can found the equation of the tangent line to the total death caused by malaria in 2007. And by applying integrals, we can found the total death caused by malaria in Nigeria from 1980 until 2012. Based on the data, malaria has been a concern to humankind since long ago. It became more popular in the 20th century and now kills 2 until 3 million people every year, especially in Africa. Gradually, the improvement in malaria treatments has contributed significantly in decreasing the disease incidence and mortality. The decline of malaria, especially in sub-Saharan Africa, has depended a lot on modeled estimations based on historical data, predictions based on sparse parasite prevalence data, and presumed impacts of interventions. This shows that winning from a disease is possible when the world collaborates together. However, there is also a possibility for us to have another malaria outbreak. The disease will always evolve. Therefore, it is our job to keep improving and maintain the world's stability. It's now understood that a one-size-fits-all approach cannot be expected to resolve the problem in every country. So, here are a few suggestions from us for future improvements. First, make a malaria expert base. Malaria expert base can be used to improve the research about malaria and make it more focused. This base is necessary to strengthen a variety of technical and health services related to malaria. Second, the responsibility of government for launching programs to distribute vaccine more equitably. Vaccine development is one of the best ways to reduce the mortality rate caused by malaria. There are some intermediate goals of vaccine research: induction of strong, strain-transiting, durable immune responses, identification of protective antigens for stage-specific immunity, and a successful combination of candidate immunogens. One of the important issues confronting malaria vaccines improvement and development in general is the relatively low level of commercial interest. Countries with most malaria cases usually are developing countries which are still struggling to ensure their people's medical needs and have low economies to support and distribute the vaccines. And the third, strengthen the health workforce. If we have to face a sudden outbreak, we definitely need many professional health workers. Expansion of malaria can be prevented by equally distributed skilled workers. Health workers are required to cater in remote and underserved populations. So that's all from our group. Thank you for listening.